Okay, today we're going to talk about graphing quadratics. A quadratic is a function that's nonlinear, so it's not going to make a straight line, that can be written in the standard form y equals ax squared plus bx plus c, where a does not equal 0. And every quadratic function has a u-shape called a parabola. Okay, so it says in this lesson we'll graph quadratic functions where b is 0. So ax squared, no b, plus c. So the first thing we have to talk about is what's called the parent quadratic function. And I'm going to make a little table of values down here, okay, where we have x and y. And I'll just write parent so we know what we're doing. Okay, so if I put in a 0, okay, the parent function is just y equals x squared. So if I put a 0 in for x, what's 0 squared? 0. So I can graph the point 0, 0. Well, what if I graphed the point 1? 1 squared is 1. So I have the point 1, 1. Well, what if it was negative 1? What's negative 1 times negative 1? Positive 1. What if I put in a 2? 2 squared is 4. So there's the point 2, 1, 2, 3, 4. What if it was 3 squared? 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's going to mirror on either side because 2 squared is 2 times 2, which is positive, but negative 2 squared is also positive because it's a negative times a negative. So what we just drew here, what I just drew, is the graph of the parent function y equals x squared. And the vertex is the lowest or highest point, so that's right here. That is the vertex. And then the axis of symmetry is the line that passes through the vertex and divides the parabola into two symmetric parts. And for today's lesson, that is going to be the y-axis. Okay, the axis of symmetry is what cuts through the vertex lies on the axis of symmetry. Okay, so what we're going to be doing today is we're going to be graphing other quadratics, but we're always going to be comparing it to the parent function. So the first thing on every one of your assignments that you're going to do is you're going to graph the parent. So 0, 0, 1, 1, 2 squared is 4, 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should look like this. Okay, that's our parent function. We're going to graph that every single time. So now we're going to graph the function y equals 3 times x squared. So we're going to pick our values for x, then we're going to plug it in to 3 times x squared, and then that's going to give us our y values. So if I put in a 0, that's 3 times 0 squared, that's still 0. So I have the point 0, 0. My dog is whining again. What if I put in a 1? 3 times 1 squared is 1. 3 times 1 is 3. So I have the point 1, 3. If I put in a negative 1, negative 1 squared is also 1. 3 times 1 is 3. So it's going to mirror. Okay, well, what if I put in a 2? 3 times 2 squared, 2 squared is 4. 3 times 4 is 12. So I have the point 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to estimate it to be about there. So I'm going to connect these. And there's my parabola. Okay, so when you're comparing it, we want to look at the vertex, the direction that it's opening, and the width. Okay, these have a vertex that are the same, right? They both have the vertex 0, 0. Really, the only thing that's different about it is we can say 3x squared is more narrow than x squared, right? That's really the only kind of comparison. When I'm looking at the graph of 3x squared, it's more narrow than the graph of y equals x squared. Okay, let's look at number 2. Okay, on number 2, we have y equals negative 1/4 x squared minus 2 we're going to graph it and compare it to y equals x squared. So I'm going to graph the parent function first, 0, 0, 1, 1, 2, 4. Okay, I'm not going over to 3 because my graph is not extending way up there. So now I have negative 1/4 x minus 2. So I'm going to pick my x values. I'm going to plug it into negative 1/4 times x squared minus 2. And I'm going to get out my y values. So let's think if I put in a 0. 0 squared is 0. 0 times negative 1/4 is 0. 0 minus 2 is negative 2. So my parabola is going to start there. Okay, let's say I move over to 1. So negative 1/4 times 1 squared. So 1 squared is 1. That's negative 1/4 minus 2 is negative 2 1/4. You might be like, what is that? So negative 1 or positive 1 down 2 1/4. Okay, about right there. Now I'm going to pick 2. So negative 1/4 times 2 squared is 4 minus 2. Well, 1/4 of 4 is 1, and it's negative. Negative 1 minus 2 is negative 3. So 2, negative 3. And then what if I put in like a 4? Negative 1/4 times 4 squared is 16. That's negative 4 minus 2 is negative 6. So negative 4 or positive 4, and then down 1, 2, 3, 4, 5, 6. Okay, so like this. And that would be my parabola. Okay, and what you can notice, there's several things. We can say negative 1/4 x squared minus 2 has a vertex. My dog is so sad that she's not with me. Has a vertex 2 units lower, opens down, and is wider than y equals x squared, right? Those are 3 observations that we can make. And then what I also wanted to reiterate or remind you guys of is that you don't have to do 0, 1, 2, 3. You don't have to do every number. I did one to show you what would happen, but if I have a denominator that's a 4 or a 2, I'm only going to pick multiples of 2 because that's going to give me easier whole numbers, right? Or if this was 1/3, I'm going to pick 3, 6, 9. Or 1/5, I'm going to pick 5 and 10. Okay, so just keep in mind, you don't have to do every single number because you're going to get decimals. It will work, but it might be a little bit more difficult. Okay, so look at the back of that page. It says a parabola opens blank when the coefficient of x squared is positive and opens blank when the coefficient of x squared is negative. So if we look at the last 2 examples, this had a positive positive coefficient, right? Positive 3. This had a negative coefficient. What do you notice is different about the purple and the pink? Positive coefficient meant that this one was going to open up. Negative coefficient is what made this one open down. Okay, so the coefficient determines whether it's going to open up or down. It's also going to determine how wide or narrow. The bigger the coefficient is, the skinnier it's going to be, right? Because think about it, if this had been 10x squared, you would have had 1 times 10 is 10, and it would have been really skinny, right up here in the middle. But over here, because it was a fraction, right, it's less than 1, that's going to make it open wider. Okay, so a parabola opens up when the coefficient of x squared is positive, and then down when it's negative. So let's look at example 3. It says graph y equals x squared plus 5 and compare with the graph of y equals x squared. So 0, 0, I'm doing my parent again, 1, 1, 2, 1, 2, 3, 4, and then 3, 9. So here is our parent function. Okay? So now we need to graph x squared plus 5. So I'm going to pick my x's, I'm going to plug it into x squared plus 5, and that's going to give me my y values. So let's say I put 0 in here. 0 squared is 0. 0 plus 5 is 5. So I have the point 0, 1, 2, 3, 4, 5. What if I put in a 1? Well, 1 squared is 1. 1 plus 5 is 6. So 1, 6. Well, what if I put in a 2? 2 squared is 4. 4 plus 5 is 9. So right up here. Okay, that's about as far as I'm going to go because I'm out of space. So let's look at what we notice. First of all, that's messed up. There we go. About these two parabolas. They both open up. They have the exact same width, right? One isn't necessarily skinnier or wider than the other, but x squared plus 5 is 5 units higher. Okay, so think about that. Look at the equation. What do you notice? Do you see how it was x squared plus 5? So 5 units higher. Look over here. Negative 1/4 x squared minus 2, 2 units lower. This one didn't have a plus or a minus anything. It didn't have a c, so it had the exact same vertex. So you can you can look at these equations and look and make your observations before you even have to graph anything. So on number 4, it says graph y equals 1/2 x squared minus 4 and compare it with the graph of y equals x squared. So 0, 0, 1, 1, 2, 4. There we go. Okay, so now we're gonna do 1/2 x squared minus 4. So just based on the equation, okay, I know it's gonna be open up because this is a positive. It's going to be wider because this is less than 1, and it's gonna start 4 units lower. So let's see if I'm correct. So we have x, 1/2 x squared minus 4, and then y. Okay, so if I put a 0 in here for x, I get 1/2 of x squared, which is 0. 1/2 of 0 is 0. 0 minus 4 is negative 4. Okay, I'm going to pick even numbers because this is a 2, right? A half. So if I put a 2 in, 1/2 of 2 squared is 4. So 1/2 of 4 is 2, minus 4 is negative 2. So when I put in a 2, I got out negative 2. Okay, and then I'm going to go ahead and put in a 4. 1/2 of 4 squared is 16. 1/2 of 16 is 8, minus 4 is 4. So I'm going to go over here 1, and then up 1, 2, 3, 4. Okay, so let's look at it. Okay, were all of my observations correct? Yes, right? So this number told me it was going to open up because it's positive, and it did. It's less than 1, so I know it's going to be wider. So 1/2 x squared minus 4 is wider. And the vertex is how many units lower? 1, 2, 3, 4. 4 lower. 4 units lower. Okay, this bottom section we're going to leave off. If you want to hang out and listen, I'll explain it. But so y equals, so let's graph the parent function first. If this was our parent function every time, let me put that on there. Okay, so what this is saying is that if you have ax squared and a is bigger than 0, so like 2x squared, 3x squared, 10x squared, that it's going to be skinnier like that. Okay, on this one, if a is less than 0, so like 1/2 x squared, 1/4 x squared, 1/3 x squared, it's going to be wider like that. And then, let's see. I messed that up because that should have been 1. And we'll just leave it at that as kind of an observation.